So this video is on chapter 9 D-Day. So on these, number 1, number 2, number 3, number 4, these are regular inequalities. What you want to remember is that you only are going to switch your inequality direction if you multiply or divide by a negative, switch inequality direction. But if you do not multiply or divide by a negative, your inequality direction is going to stay the same. So on number 1, I'm going to add 4 to both sides. I'm going to have 3x is still greater than 21. I am going to divide by 3. I'm going to divide by 3. It is a positive 3, so I'm not going to switch the direction of my inequality. So x is greater than 7, so that is going to be my solution. And in terms of a graph, I'm going to have 7 here. I'm going to have an open circle, and greater than is this direction. And so that's my graph. Open circle, shade to the right. On number 2, the one thing you do want to pay attention to is that your x is on the right-hand side, where this one, your x was on the left-hand side. If your x is on the left-hand side, the direction your inequality is pointing, let me try this one more time, is pointing. Notice it's the direction you shaded, okay? But if it's on the other side, it's going to be the opposite. So you guys got to be careful, or read it and out loud to yourself and see where you should be shading. Okay, so I'm going to add 15 to both sides. I'm going to get 40 is greater than or equal to 10x. I'm going to divide by 10, divide by 10, and that does not switch the direction of my inequality. So I'm going to have 4 is greater than or equal to x. So you can write your answer one of 2 ways. You can keep it as 4 is greater than or equal to x, or instead you could have written it, and I'll do this in green. You could have, since 4 is greater than or equal to x, that means x is less than or equal to 4. Okay, these are the same answer. It's just one is written with the x on the left-hand side, the one in green, and the first one, the top one in pink, it's on the right-hand side. So I'm going to have 4. I'm going to have a closed dot. And again, you'll notice that my x in this situation is on my right-hand side. And I'm going to shade the opposite direction from my inequality, the way it's pointing. Okay. And so this is going to be my graph. And again, either answer is the same. You could write them in either form. You do not need to give me both of them. On number 3, I am going to keep my x where it is. I'm going to -2, -2. Don't forget that there's a negative in front of that x. So it's a -3x is greater than or equal to 15. I'm going to divide by a -3. So when I divide by a -3, this side I get x, this side I get a -5. And when you divide by a negative, I need to switch the direction of my inequality. And so I'm going to have x is less than or equal to -5. So I'm going to have a -5 solid dot. And I'm going to be shading to the left, as I want x's that are smaller. On number 4, on this one, I personally, if I have x's on both sides, I like to deal with my x's first. So I need to get my x's on one side, so I'm going to add 2x. Now, when I do that, I'm going to get a 9 on this side, less than or equal to, because those x's cancel, 10. And again, on the other side, my x's also cancel. That's what I'm left with. You need to decide if this is true or false. 9 is less than or equal to 10. It is true. Okay. It needs to make either the less than true or the equal true. Okay, and 9 is smaller than 10, so it makes the 9 is less than 10 part true. Okay, so this is true. So what does that mean? It means that everything's a solution, all real numbers. And in terms of your number line, you're going to graph everything. Everything is going to be shaded. And that's your answer. On number 5, this is an absolute value equation. Okay, so on these ones, what's really happening here is this value here. Let me just kind of shade this for a second. This 2x minus 1, okay, that thing inside my absolute value. Remember, that could have been an 11 because the absolute value of 11 is 11, or I could have had a negative 11 in there because the absolute value of a negative 11 is 11. So I am going to take this 2x minus 1. I am going to set it equal to 11 to see what makes it an 11, and set it equal to negative 11 to see what would have made it a negative 11. And then I'm going to solve both of these. So I'm going to add 1. I end up with 2x is equal to 12. So x is equal to 6. So that's one answer. X is equal to 6. And then for my other one, I'm going to add 1. And I get 2x is equal to negative 10. I divide by 2. I get x is equal to negative 5. So I have both of these answers, because if I was to go back into this problem and I was to go 2 times 6 minus 1, that's 12 minus 1, which is 11, and an 11 minus, 11, absolute value of an 11 is 11. If I had put in a negative 5 in here, 2 times negative 5 is a negative 10. Negative 10 minus 1 is a negative 11, but the absolute value of negative 11 is 11. So both of them work. Okay, that's why I take what's inside my absolute value, I set equal to the positive 11, and I take what's inside my absolute value, I set equal to a negative 11. Okay. Okay. On number 6. Now on 6, unlike 1 through 4, this is absolute value. I would personally write this as an equation like this. And so let's solve this as an equation, which means I'm going to work out 2 problems. I'm going to work out x minus 2 is equal to 4, and x minus 2 equals a negative 4. The top one, I'm going to add 2 and I get a 6. On the bottom one, I'm going to add 2 and I get a negative 2. So I'm going to have a negative 2 and a 6. And if I look back at this original problem, it's open circles. And I need to decide if I'm shading in between or outside. So I'm going to put a number in. The number I'm going to test is 0. You never want to test the numbers you got because that makes it equal. We want to see what makes it less than. So let's say I put a 0 in here. Absolute value of 0 minus 2 less than 4. Absolute value of negative 2 less than 4. 2 less than 4. So it's true, and 0 would be here. And this made it true. I'm just going to write it so people see it. This made it true. So since that was true, I'm going to shade where it's true. And that's going to be in between. Okay, so I have an open circle at negative 2. I have an open circle at 6. I shade in between. Now, the way I write that answer when it's these in between ones, start with your smaller number. Less than or equal to if it had a solid dot. X, and again, still less than 6. Those inequalities need to point the same direction. On number 7, I can do this one of 2 ways. I can get the to be in Y form, or I can find my X and Y intercept. So if I'm the type that likes to find my X and Y intercept, I go 4x equals 8, which means X is 2, and Y equal 8. So I've got 8 for my Y and 2 for my X. So 1, 2, 3, 4, 5, 6, 7, 8. I'm off by 1. Okay. And 2. And then this is going to be a solid line. Let me actually use a line. Okay, it's going to be a solid line. Oops. Trying to use a line. Try it one more time. And for this, I'm going to get my up here, click on the select. I can click on this if I need to change it to dash, which I don't. I'm going to put the arrows at both ends. And I might also just, there, it looks okay. Okay, so there's that. Now I need to decide if I'm going to shade above or if I'm going to shade below. So if I'm reading this, and hold on, let me just get off of this. Okay, if I'm reading this, and you want to be careful, okay? You want to be careful because this is not in the Y form, but this is a positive Y. So that means I'm going to not change the direction of my inequality because I'm not going to divide by a negative. So this is greater. So greater is going to be here. I'm going to shade everything here. That's going to be my answer. If you don't feel comfortable doing it that way, then what you can do, and I'll do this in pink, is take this, let me do it in a darker pink, take this and get it in Y form. So minus 4x, and when I minus 4x, that does not change the direction of my inequality. So you see I have my y-intercept at 8, which is what I had before, and I'm going to go down 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. You see I got the same line. On number 8, this one is in Y form. I have a y-intercept at -2, and my slope is 3, so I'm going to go up 3 over 1 to the right. And let me get my line. And for this one, it is going to be solid. And let me just put my arrows, and I'm just going to move it a little bit. Okay. And this is y is greater, so that means I'm going to shade above. And that's going to be here. Okay, on number 9. So this is a system. I'm going to graph one in one color, one in another color. Okay. So I'm going to graph this first one in, let's say pink. So I'm going to start with this one at -1, and then I'm going to go up 1 over 2. So I'm going to start at -1, and then I'm going to go up 1 over 2, up 1 over to the right 2, up 1 over to the right 2, and so on. And then backwards, I can go down 1, left 2, and so on. And this one is going to be a solid line. So there's that line. Just a little bit, a little off. There you go. And put my arrows. Okay. And for this one, it is greater. So I'm going to shade above. So I'm going to be shading here. Let me just hold on a second. Okay. So this is where I'm shading. Okay, so the next one, let's say I do that one in blue. So that one I'm going to be starting at 4. 1, 2, 3, let's see, 1, 2, 3, 4. And then my slope is a -2, so I'm going to go down to right 1, down to right 1, and so on. And this one's going to be a dashed line this time. So let me just draw my line through. Oops, doesn't need to go through that, sorry. That was not one of my points. Here it is, okay. And this is going to be dashed. And then for this one, we want less than. So I'm going to shade underneath it. So I'm going to shade underneath this. Let me make this a little darker. So you can see that over here, this just makes my first one true. This makes neither equation true. This makes my second one true. This makes both true. So this is going to be kind of where your answer should be. Okay, this is our answer here. Okay, that's your answer. That's where both of them are. Okay. On number 10, okay, we're going to graph these. So let me again graph the first one in pink. So we're going to start at a -1, and then I'm going to go up 1/2, which was the same one I had on the other one. Okay. This is a solid one. Oops, trying to get a line. Okay. And let's see, the next one, let's say I do in blue again. Let me just try to get rid of this. There you go. Okay. And so this one, if I get this into y form, this is going to be y is less than -2x plus 4. So I am going to be starting up at 4, 1, 2, 3, 4. And then I'll be going down 2 over 1. And this is going to be the same situation I actually had on the other side. They want this to be less than. That means I'm going to shade below. Okay. So hold on. I didn't shade the other one. This one was shading greater, so I'm going to shade above. This one I'm shading less than, so I'm going to shade below. And you can see that my answer is where the 2 colors is. Again, it was the exact same graph as the last one. It just was set up in a different form at first. So this is going to be our answer. And again, this was a dashed line. I think my line disappeared. There you go. Okay. And on number 11, what is the difference between the solutions between points A and B? So point A, let me just kind of make sure everyone understands this. This is makes only the line inequality true. here in the blue makes only the, and I'll say exponential, looks like an exponential, the exponential inequality true. Here makes neither true. And then this one makes both true. So A is not a solution since only makes one true. B is solution because it makes both true. Okay. On number 12, write the inequality for this. So I'm going to have my x. It's going to be less than or equal to 1. That's my inequality for that picture. Then it's asking, is 3 a solution? Well, 3 is here. 3 is not in the shaded area, so not a solution. Then they give us -1. That's where -1 is. Yes, since it is in the shaded area, yes, it is a solution. And is 1 a solution? So 1 is here. Now this is where we got to pay attention. This is going to be a solution because this was a closed dot. So yes, since closed dot. If it had been an open dot, then that would not have been a solution. Okay, so let me do the same idea. Okay, 0, 0, let me zoom in, 0, 0. Well, that's not in the shaded region, so not a solution. -6, 0. -6 zeros over here. So yes, a solution. And then 0, 1. So 0, 1. Let me zoom in, 0, 1. So it's going to be here. Now it's on dashed line. So if it's on the dashed line, it's not going to be a solution. If it had been a solid line, it would be a solution. So this one is not a solution. Okay. Similar idea on 14, except for on this one, we have a system this time. So let's see, 0, -10. So 0, -10 would be somewhere down here, which this would have extended and this would have been shaded. Okay. So this is, this would have been down here and it would have been shaded, but it would have been shaded. It looks like that's kind of a red. So this would have continued down here like this, okay? The problem is that when I put this dot in here, okay, so let's say this one's this one. So 0, -10 is going to be somewhere down here. This is not a solution because it's not where both of them are true. So that's not a solution. 6, 0, 6, 0, let me zoom in. 6, 0 is on the line. So on line of double shaded area. So that means, yes, this is a solution. And then they gave us this 1,000, 0. So 1,000, 0, I'd be going out, 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 out forever and ever and ever and ever and ever, not forever and ever and ever, but out to 1,000, and I'd have my point here. And that is in my shaded region. So yes, this is a solution. And that's the end of this video.